solving linear equations with integer multiples of x. And so again, we will be using the same materials for this work. We have our units, and each tile is worth 1. We also have our x pieces, and for every x piece, it's worth the same amount. And then we have our negative tiles, which is worth -1. For the previous lessons, we have been told that whatever is in our left side should be equated to that of the right side. This is the set balance in our equation. With this example of an equation, we have x is equal to 4. Now let's say we have this equation. We have 4x pieces and 12 units. We want to know how much each x piece is worth to make our equation balance. Now what do we have here? We have 4x pieces and there's 12 of our units. We can write it down as 4x is equal to 12. We want to know how much each x piece is worth to make our equation balance. Can we tell what it is right now? Well, with this equation, it's quite obvious that x stands for the amount of 3. How can we show this? We want to get one x piece all by itself. How could we get rid of these other 3 x pieces? Subtract them? This is a different type of question than the others we did. What makes this different? The fact that we have more than one x piece is what is different. So we cannot subtract. We can't say that 3 less than 4 x's. So we can't subtract. What we can say is that 1 is 1/4 of 4. So we took this side and split it into fourths. Why fourths? Because we had 4 times as many x pieces. Now we must do the same to the other side. Now we have 4 groups. Now we were able to group them into 4 groups. We can take just one group from each side. So x here is actually equivalent to 3. What did we do to both sides of our equation so that we can represent this in the writing? We took 1/4 of both sides. What did we do to both sides of our equation so we can represent this in the writing? Again, we have 4x is equal to 12. We took 1/4 of both sides. So 4x times 1/4 and 12 also multiplied to 1/4. So 1/4 of 4x is the same as 1/4 of 12. So 1/4 of 4x is the same as 1/4 of 12. X then gives us 3. How else could we think of this? We could have said that we divided both sides by 4. This way we could see what the unit has. So we have here 4x over 4 is equal to 12 over 4. Well, we could also use the division symbol, but we will see that it is generally less confusing to use the fraction bar for division. Simply, we will arrive at x is equal to 3. Let's take another example. Here we have -3x is equal to 15. Here we have to do 2 things. If we take 1/3 of each side or divide both sides by 3, will we have one x piece? Well, almost. We will have 1, but it will be negative. Now let's do that with our materials. Since there are 3 negative x pieces here, we will divide then the group into 3. Okay, so we have here for our units, there is going to be a group of 5. So here we have -3x over 3 will still end up with -1, while 15 over 3 gives us 5. Now it shows with our materials here that for every negative x piece gives us a group of 5 units. But then again, our x is not just x alone, it's a negative x, which is equivalent to 5. So if the opposite of x is 5, then what would the x be? Yes, negative 5. So if we take the opposite of one side, we can take the opposite of the other. So in here, we now have x is equivalent to negative 5. We can do more examples, including those with x on the right. This time, I'll leave you with these equations to work on. 5x minus 3 is equal to 12, and negative 2 plus 8x is equal to 38.